Welcome back. In today's second video lesson, we're going to continue looking at how we can apply the Pythagorean theorem to solve word problems. The second example we're looking at asks us to find the perimeter of a triangle with side lengths of 29, 20, and m. Take some time to try to figure out on your own what is the perimeter for the triangle shown below, and then we'll walk you through it. Welcome back. The first thing I need to know to solve this problem is what perimeter means. Today's key term, the second key term, told me that perimeter is a measure of the total distance around the edge of a figure. You've worked on perimeter a bunch of years in prior math, so hopefully this is familiar. Perimeter is the distance all the way around a figure, or in today's case, the distance all the way around this triangle. To know the perimeter, I need to know all three side lengths. I only know two, but now I should know the Pythagorean theorem will help me find the third side length, the key piece of info we're missing that we need to answer this word problem. Which formula is going to be easier to use? Think about that for a second. We know what the hypotenuse is, the long side. C is going to be 29. We know one of the legs, but we don't know another leg. So I would be using the c squared minus a squared equals b squared variation, because that's just a little bit easier to work with. In this situation, I know that c is 29, and I know that a is 20. So because of that, I want to pick the formula where c and a are on the same side of the equation so that they can quickly combine after we square those two side lengths. 29 times 29, or 29 squared, is going to give us 841 when we do 29 times 29. And then we have to subtract whatever 20 squared is. If I know 2 times 2 is 4, then I know 20 squared equals 400. So our equation, after we evaluate the exponents, becomes 841 minus 400 is equal to b squared. When I evaluate 841 minus 400, 800 minus 400 will leave us with 400, and I also need to account for that extra 41 there, so we get 441. You could do the algorithm if you're not sure how to do mental math there. You could use a calculator because they're available. The final step, how do we cancel out the squared that's attached to our b? We want to know at the end of the day what b is equal to. The way I cancel out a b squared is by applying a square root to it. And if I apply a square root on the right side of my equation, I have to do the same exact thing on the left side of the equation to keep that part balanced. I don't know what the square root of 441 is. I know it's going to be close to 20 because 20 times 20 would give me 400. But to get the exact answer, I'm going to need a calculator to help me figure out the square root of 441. Oh, it turns out it's 21. This was one of the perfect squares. I just didn't know that at first until I used the calculator. If I know that side m is 21, and I know that perimeter is the three side lengths of the triangle added up, I'm going to do 20 plus 29 plus 21. The three 20s added together, 20 times 3 gives me 60. Plus 9 plus 1, and when I add the 9 and 1, that gives me 10, or bumps up the perimeter to 70 units for the perimeter of the maroon triangle.